Okay, this question deals with a very specific issue called imaginary numbers. And there's not a whole lot you need to know about imaginary numbers, but there is a little bit. It doesn't show up on every exam, but it does show up. First of all, there's a little bit of crossover with the idea of FOIL first, and you need to make sure that you're very familiar with how to expand using FOIL. So if you have two expressions like x plus 4 times the quantity x plus 2, say, remember that FOIL, F means first, so you multiply the two first terms, you would get x squared. O means the outer one, so you multiply the two outer terms, so that's x and 2 here, so you get plus 2x. I means inner, so you multiply the two inner ones. In this case, that's 4 and x, so you get 4x. And then L means last, and the two last ones are 4 and 2, which would be plus 8. And then you just have a little bit of cleanup here in the middle to do. 2x and 4x would be 6x. So this would end up being x squared plus 6x plus 8. So that is important because right here, the imaginary numbers, you handle them just like you would a variable, and all the properties of addition and subtraction, multiplication, division apply to the imaginary number set just like they do to every other number set. So FOIL is going to apply in this situation. Now there's two properties that you need to know about with imaginary numbers, and this is really the crux of the whole thing. The first is that, first of all, imaginary numbers are represented by this term I. And really all it is the concept that I squared equals -1. So in our real number set, we don't have a way of identifying how you would get a number squared to equal a negative, let alone -1. So it's just by definition, I squared, imaginary unit, squared equals -1. And then there's also the corollary. If I squared equals -1, then the square root of this side, I squared, if you took the square root of I squared equals square root of -1, the square root of I squared would just be I. So these are the two things. I equals the square root of -1. These are the two main properties that you need to remember. I squared equals -1, and then the square root of -1 is I. And like I said, it handles just like if you had 3x, you could also have 3i. And I'll show you how to handle those later on, but you treat them just like you would a variable. There's also the idea of complex numbers, and all that is when you add into the same set both real and imaginary numbers as a plus bi, where I is the imaginary number. So you have these two constant real numbers like this, a and b, so that would be like 4 plus 6i. I don't know whether to tell you about this fallacy or not. Go into why imaginary numbers. I don't know how to do this in a very short explanation, but numbers in general aren't real things. It's any number set that we have, whether it's integers or rational numbers, irrational numbers, they are an attempt to represent using symbols something that does exist in the real world. Just like if I wrote the word tree and I said the sound tree in your head, you would put meaning to that. There's no meaning in the sound of the word tree. The meaning is what you interpret that to mean. There's no meaning in these symbols right here. They don't equal the actual thing. They are just symbols on, well, this isn't even symbols on a piece of paper. This is just symbols in pixels that are transmitted over using zeros and ones over, using electricity, and there is no intrinsic inherent meaning in them. And if I said one tree, there is no inherent meaning in this right here. It's a symbol to represent. If there actually were a tree outside and there was just one of them, this is the way that we would represent that. Well, imaginary numbers, if you can, we have a number line. This is just one way to look at it. If you were counting in this direction, 1, 2, 3, 4, how do you represent things that are to the left of 0? Until we start looking at negative numbers, we couldn't represent that idea. But now that you understand the negative side of the number line, you can represent that idea. Well, what about the square root of 2? The square root of 2 doesn't fit on this number line. We can't really express it using these numbers, these real numbers, or these numbers, because this is an irrational number. It's somewhere in between there, but you can never actually get to it using this set of numbers because it just keeps going. 1.41, it just keeps going and going and going. That's an irrational number. So what about the square root of a negative? The square root of -1. We have no way of representing that concept. The thing really does exist. There is such a thing that would allow it to exist. We just don't have a way of representing it, and that's by definition how they came up with I. I by definition just is the square root of -1. You probably don't need to know any of that for the exam, but this you might, and that's how I raised to exponents. I to the 0 power is just 1. Anything raised to the 0 power is 1. I to the 1, anything times itself is just the thing. So this so far shouldn't be unfamiliar to you. This is just straight out of math that you've already had. Now here is where the definition comes in. I squared equals, by definition, -1. So that's the first idea that might be a little bit different. I to the third simply is I squared times I. And I squared was -1, so that equals -1 times I, which would then equal -I. And then I to the fourth would be I to the third times I, and I to the third was -I, so that's just -I times I, which equals, you can do the same thing that you would with an exponent and distribute the ones. So this is -1 times I times I. I squared is by definition -1, so this equals -1 times -1, and that is just 1. So now let's keep going. I to the fourth, then you have I to the fifth, which is just I to the fourth times I, and I to the fifth was 1 times I is just I. And then I to the 6th would be I to the 5th, which was just I. Well, I to the 5th times I equals I. That was I to the 5th is just I times I equals I squared. And by definition, I squared is -1. So now you can see it follows a pattern. 1, I, -1, -I. 1, I, -1, and the next one would be -I. So really it follows this pattern. 1 I, 1, then I, then -1, -I. 1, I, -1, -I. And it just repeats and repeats and repeats how it would just keep going. So this might be useful on the exam, and this definitely will be useful. If they're going to test the idea of imaginary numbers, they're going to use this property of I squared is -1. The square I is the square root of -1. Okay, let's go ahead and answer this question. From what we put together here, it'll probably be very easy now.